when you are looking for symmetry in your graphs, you want to look for symmetry 3 different ways. So the first way is with respect to the y-axis. And that you will see will be very easy because every point x, y will have a point opposite on the y-axis. So negative x, y would also be a point on the same graph. So an excellent example of that is y equals x squared that we did in an earlier slide. So that was going to be something that we have some definite symmetry over the y-axis. If you want to test it, all you have to do is take the function, and if you replace x with negative x, you should still get exactly the same function back again. And again, if the equation's in 2 variables, you would just replace the x with negative x, and you should still end up with the same y value for everyone. So we'll do some examples of these so you can see what they look like. You could also have symmetry with respect to the x-axis, and that is where I could use the x-axis and fold it over. So every point x, y would also be mirrored with the point x negative y below the x-axis. If you are looking at your equation, if you put a negative in front of your function, it's going to be exactly the same function regardless of whether that negative is there or not. So if your equation's in 2 variables, you would replace your y with the negative y, and you should end up with the exact same equation regardless. The last type of symmetry that you could have is what we call origin symmetry, and that is where, and this is hard to explain, but if you take the graph and you pretend that think a graph as a doorknob, and the center of the doorknob is the origin. If you could take that doorknob and your graph and you could turn it 180 degrees around that origin and it still looks exactly the same, then that graph has origin symmetry. So that means every point x, y will also have the point negative x, negative y on the graph as well. So if you were doing the algebraic test for that, you would take x and y, make them both negative, and when you clean everything up, it should still look like the exact same function that you started with. So we are going to do some testing, the testing from the algebraic end. When you're doing these when you're looking at the graphs, it's very easy to see. So we're going to save that for a little later. So we're going to focus on the algebraic tests right now. All right, so here we have this graph y equals x squared minus 1, and I want to know, is that symmetric with respect to the y-axis, the x-axis, or the origin? Okay, so we're going to test each one individually. So this is how you test the y-axis. So I'm going to do each one. So if you're testing the y-axis, you're going to take that function and you're going to plug in a negative for x. So every place you see an x, put a set of parentheses, plug in negative x. If I clean that up, notice it comes out exactly the same as the function I started with. So this does have y-axis symmetry. So if I were to graph this, I would be able to fold it right over that y-axis and it would land right on top of each other. All right, let's test for x-axis symmetry. So if we're testing for x-axis symmetry, you're going to replace y with negative y. So the y would become negative and the x squared minus 1 part would stay the same. So if I cleaned this up and solved for y, notice I don't get exactly the same equation. So this has no x-axis symmetry because we ended up getting back a completely different equation than the one we started with. And if you are testing for origin, you're going to change both. So the y is going to become negative and then make the x negative. And then clean the whole thing up and see what happens. So when I square the negative x, so that'll just be y equals x squared minus 1, and then I'm going to make everything negative to get the y by itself, and I get negative x squared plus 1, which is obviously not the same. So it has no origin symmetry. So those are the 3 tests in their algebraic form. Again, not difficult. You just have to remember which one you're making negative and when you're not. So if you're doing y-axis, the x becomes negative. If you're doing x-axis, the y becomes negative. And if you're doing origin, they both become negative. So that's kind of the easy way to remember. All right, so if you would like to try one, you can go ahead and press pause and go through, and we will see when you get back. All right, so let's go through our 3. Let's start with our y-axis. Okay, again, y-axis symmetry, we're going to make the x negative. So if I make the x negative and I keep the y the same, If I clean that up, notice I do not get the same equation. So that's no y-axis symmetry on this one. No y-axis symmetry. All right, now let's test for the x-axis. So x-axis symmetry, we're going to make the y negative. So x stays the same. This time the y value becomes a negative. All right, clean it up. We get x equals y squared minus 2. Oh, so it's exactly the same. So we do have x-axis symmetry. So that's a plus. All right, and then let's test for the origin. So origin symmetry, you're going to make both of them negative. So I'm going to make the x negative, and then I'm also going to make the y negative. And then clean everything up. So I get negative x equals y squared minus 2. And then make everything negative, so I get the y by, so that would be x equals negative y squared plus 2. Not the same, so there's no origin. So no origin symmetry. So notice tests, not difficult. Just got to plug in one of those. All right, one more. Try this one. All right, so if you want to press pause and go ahead and try it on your own. All right, let's see how you did. All right, so we're going to go through and test each one. So let's start with our y-axis. So again, y-axis, remember you're plugging in x is negative. So the x becomes negative, and the y we just leave alone. So notice when we square that negative x, it still comes back to positive. So that's good. This graph is going to have y-axis symmetry. So y-axis is a plus. All right, now let's go look at the x-axis symmetry and test for that. So x-axis, you're going to make the y negative, so the x squared is going to stay the same, but the y is going to become negative, and then square it. Notice when you clean that up, you will get x-axis symmetry. So x-axis is a plus. All right, let's test for origin symmetry, where I can turn it around 180 degrees. So origin, you're going to make both of them negative. So the x becomes negative, and the y becomes negative. And when you clean that up, notice square and negative, they both become positive again. So this one also has origin symmetry. So this is all three. So origin is a plus here as well. So this graph, when I graph it, it will have all types of symmetry that I can look at. So that will be a fun graph to look at. All right, sometimes in algebra, to make things a little bit easier for us, they'll talk about odd and even functions. Now, odd and even functions have to do with symmetry, so that's the good news, is we don't have to learn anything new. Even just means that there's y-axis chemistry. Did I just say chemistry? I meant symmetry. Weird. Okay, so even goes with, even functions have y-axis symmetry. If you are an odd function, you have origin symmetry. So odd and origin both start with O, and that's how I remember. Even goes with Y, like why even am I taking this class? I have to because it's for my major. So Y goes with even, odd goes with origin. So if they ask you if a function's odd or even, they're just asking for those two specific types of symmetry. And I had a student ask me once, why doesn't X get 1? I have no idea. I honestly don't know. So if anybody can find the answer for that, please, email me and tell me why the x-axis symmetry didn't get something special like this. All right, so determine if this function is odd, even, or neither. Okay, so if it is even, that means it's going to have y-axis symmetry. So when I do y-axis symmetry, so even, let's write off even, remember that's going to be y-axis. So you're going to make your x negative, and if you want to, you can change from function notation to y equals. Some people just feel more comfortable with that. If you want to do that, that's perfectly okay. So y-axis means you're going to make the x negative. So y equals, I'm going to take that x, I'm going to make it negative, and then raise it to the 5th power, and then add 1. Well, if I raise a negative number to the 5th power, it is still negative. So y equals negative x to the 5th plus 1. So that is not the same function. So this is not even. It does not have y-axis symmetry. And if you want to check for odd, again, that's origin symmetry. So origin, you make both of them negative. So the y would become negative and the x would become negative. And then I would clean it up. So negative y equals negative x to the 5th plus 1. And then we would change the signs on everything to get the y by itself. And that would give me x to the 5th minus 1. Which, if you notice, not the same function, unfortunately. It was so close. That was just a +1 instead of a -1. So it is not odd either. So this function is neither odd nor is it even. So again, make sure you test everything. Don't just assume, oh, it's even, it must be odd. Not necessarily true. So make sure you do the tests. Don't get lazy. All right, so here's another different function. G of x is x to the 4th plus 2x squared plus 1. Okay, we're going to test again whether it's even, odd, or neither. So let's start with even. And again, remember, even is y-axis symmetry. And again, if you feel more comfortable, you can make that y equals. I do it all the time, so I encourage you to do that as well. So if I'm testing for y-axis, I'm going to make all the x's negative. So y equals negative x to the 4th power plus 2 times negative x squared plus 1. Notice if you take a negative number to an even power, it's still going to be positive. So this is going to be y equals positive x to the 4th plus 2x squared plus 1. So notice you do get exactly the same. So this function is even. Okay, it does have y-axis symmetry. All right, now let's go check for x-axis symmetry. So, I mean, not x-axis symmetry, origin symmetry. So origin symmetry, that's going to be odd. Whoops, just spelled odd wrong. Okay, odd. That means you're going to make both of them negative. So you're going to make the y negative and you're going to make the x negative. So check both of those. Okay, so again, we know that this side, it's just going to end up as positives because when you square a negative, they stay positive. But then we've got this negative in front of the y, so that means we have to change the signs on everything. So that is definitely not odd. So it is not odd. We did not have origin symmetry. So that function is strictly even. All right, so hopefully all of these tests for symmetry helped. Come back and we will start putting all of this stuff together that we just talked about. So the last couple of videos, we're going to smush it all together and do some examples. So I'll see you then.